Hello everyone and welcome to today's review session. Today's review session is going to be about NLTK. So let's get started with it. NLTK stands for Natural Language Toolkit and helps us tokenize documents, sentences, words, and provides more analysis tools. I will be going through the NLTK notebook command by command and explore its tools. Starting from the scratch, let us import the NLTK library. We then download the Gutenberg package and we load in the text from Lewis Carroll's Alice in Wonderland via the Gutenberg package. NLTK also provides other texts from Gutenberg. We can view those by running the following command. As we can see, there are a number of texts available via the Gutenberg collection. There are many more text datasets provided by NLTK. For now, we will just focus on what types of analysis tools NLTK provides to us on the next Alice in Wonderland by Lewis Carroll. First, word count. How many words are contained in Alice in Wonderland? Note that this includes punctuation as well as traditional words. So on running this, we find out that there are 34,110 words available. If we choose to see the first four words, we can see that we have a square bracket, we have Alice, we have an apostrophe as well as a letter S. How many unique words are present in Alice in Wonderland? For instance, the above line would count the word the on each occurrence. So we need to know the unique words that are there. For that, we can call the set function, and we see that there are 3016 unique words in the Alice in Wonderland text. Going ahead, we we can also know the word count. How many times does a specific word occur in a text? To see how many times the word Alice occurs, we call the count function on the word Alex, and we see that it occurs for a total of 396 times. Following next, we have concordance. So concordance shows occurrences of a word in context of use. We can check whether the term Alice appears in Alice in Wonderland to know the context of the word used in the specific text. So when we call the concordance function on the Alice word, we see that there are multiple matches, and this displays 25 out of the 398 matches that we have in which Alice was used. And knowing the sentence, we can know the context in which the word Alice was used. Going ahead, we have a dispersion plot. So that's a location of where a word is in the text. Example, if we have to give a visual representation of where the words Alice, rabbit, hatter, and queen appear in the Alice in Wonderland text, we call the dispersion plot on a list of such words. And we can see that the output shows that Alice is everywhere throughout the text, whereas we can see fewer occurrences distributed throughout for rabbit, hatter, and queen. Going ahead, we have frequency distributions. What are the most frequent words, especially tokens that are used in a given text? Especially if we want to generate the most frequent tokens in Alice in Wonderland, we would call the frequentist function for the Alice text, and then we can see the output for it. We see that we have a lot of punctuations in this sentence, and hence in order to remove this kind of punctuations, we try to call the method is alpha so that we have only words that are relevant to a specific text rather than getting extra words such as punctuations. On doing this, we see that the punctuations are removed, but we still have other words that are not that useful, words such as it, as, the. So in order to overcome this problem, NLTK has a NLTK has stop words. So these the type of common English words that are referred to as stop words are identified by NLTK, and then it is easy to filter these words out so that we can only have those words that are really useful for us. So if we go ahead and on downloading stop words, we can filter them out and we can filter the punctuation marks to see that we get a list of the most common words used. These are the words that we could further use for processing. Now, coming to part 2, we shall pepper in a few NLP terms from time to time to reduce the overwhelm of encountering too many new terms all at once. The first one is hypaxis. These are the words that occur exactly once in the text. So when we call the hypaxis function and to see the top 25, the first 25 words, we see that we get Lewis Carroll 1865. All of these words occur just once in the text. Going ahead, we have collocations. Collocations are a pair of group of words that are habitually juxtaposed. A general example may be red wine. In the context of Alice in Wonderland, a more specific example may be something like red queen or white rabbit. So when we call the collocations function, we see that we get the output as mock turtle, March hare, white habit. Some of these might be useful, some of these might not, and it depends on us how we use it. But collocations is a good function to know the juxtaposed words. Going ahead, we have so when we recall in part one, we ran the command indicate or download. The command was responsible for downloading various collections of text that we can use to run various NLP functions on. Thus far, we have made use of the Gutenberg collection of text to read in Alice in Wonderland. There are a few more things to note about how one may access the Gutenberg data. Now, if we see, now let us again use the words. We put it in Alice words, and on printing those words, we see that Python won't print all of the words. The ellipsis sequence denotes that there is more content that is suppressed from the output. Then we download the punked collection, and now we have now let us see the sentences that we can get from the Alice in Wonderland text. So to start with, we would print the sentences that we could get, and we see the first sentence is Alice's Adventures in Wonderland by Lewis Carroll. The second one starts with chapter 1. After sentences, we can even have characters that we want to see. So in order to get those characters, we can have the top any amount of characters that we would like to see. With the above characters, words, and sentences extracted from Alice in Wonderland, we can make use of these to calculate some cursory information on the text. For example, average word length. To find the average word length, we can take the total number of characters divided by the total number of words, and we can see that the output of such a thing results in 4 in case of Alice in Wonderland. Going ahead with the same formula, we can also calculate the average sentence length, which would be the total number of words divided by the total number of sentences, which we get as 20. Now, let us turn the above two metrics into function and determine the average word length and sentence length of all the texts in the Gutenberg collection. So we define our two methods here, and then we calculate the number of characters, number of words, and number of sentences for all the files in our Gutenberg collection, and then see how and then we can compare the average length of sentences and average length of words. On running this, we can see that we get different we get all the files, and then we get the average word length of each file, and we get the average sentence length also for each file. We can see that the sentence length tends to vary while word length among all of these files is a bit consistent. So the Gutenberg affiliates only have a small subset of text compared to the large amount of content found on Project Gutenberg. But this doesn't mean that we cannot access the contents from the Project Gutenberg. If we wish to process a text from Project Gutenberg via the web, we might use the URL lib module to import via the internet. On running the given code, we can see that we can extract the raw content, and now this can be converted to something that NLTK can understand and process. This is familiar to what we did in part 1. Going ahead and converting into text, raw text, we can process it just like we've done it previously. For example, we have converted the text object here to a frequency distribution, and we can calculate the hypaxis. Hypaxis, to remind you, it's the number. Hypaxis means the number of times a word is repeated just once, exactly once. We see underneath the hypaxis for the first 15 words, we get the title, author, as the words that are repeated just once. Now, the above approach is not limited to text from Project Gutenberg, but is broadly applicable to any text that can be obtained from a direct URL. Let us consider another text resource that NLTK allows us to process. One of them is various web and chart data. The first one we shall focus on web text. So we download web text using the NLTK library. We go ahead and we print out all the files that we get from the NLTK library. To just give you guys an overview of what these files contain, Firefox is Firefox support forum. Grail is the movie script from Monty Python and the Holy Grail. Overheard is just a overheard conversation in New York. Pirates.txt is a movie script from Pirates of the Caribbean. Singles.txt is a singles ad, while wine.txt is fine wine dairy reviews. Diary. Oops, my bad. Observe that many of the ways in which we can access the processed text from Gutenberg carry over the processing the web data text. This is a common theme for all of the text resources provided by NLTK and makes it easier to apply functionality for one text resource to another in a general fashion. So let us calculate the length for all the words, the characters, and sentences from the grail.txt. We call our functions average word length and average sentence length to calculate, and we get the average word length as 3 and the average sentence length as 9. Going ahead, we can also download the inaugural package. The inaugural package is a collection of presidential inaugural addresses, the speech that the president makes prior to officially starting their term in office. Let us print out the files provided to us by the inaugural corpus. So we see that in this case, we have multiple files right from 1789 till 2017. Each file consists of the format XY, where X is a 4-digit year and Y is the last name of the president giving the inaugural address. We can loop through each addresses. While doing so, let us keep a running tally of the number of times the word America is used in each addresses. So let's loop through the inaugural addresses. We see that kept a count. We've kept a count, and it's better if we lower every word and then we check it with America. And whenever we come across one, as we can see it in the code, we increase the count by 1, and then we use and then in order to know the president names, we take it from the fields text, where we start from the fifth index to the last negative fourth index from the back. Going ahead, we print the number of times the president has used the word America, and there we have it. President Washington has used it had used it 2 times. We could even go ahead and plot this using the frequency disk. So I also want to see how many times the word citizen is present in each of these inaugural addresses. It may be preferable to consider a plot output as opposed to one that simply outputs to terminal. So we can consider a conditionally frequency distribution. It is similar to a frequency distribution, however, it runs under specific conditions. So NLTK provides a conditional frequency function as well, which takes a list of pair. Each pair is of the form condition event, which basically means that once the condition is true, then we can go ahead with the event. In our case, the word America or citizen is the condition. Basically, once we encounter the phrase America or citizen, we go ahead and we then print the events for this. In our case, the events would be the year they were used in. So we see that we have used the words America and America and citizen in the cases, and when we find those words, those are target words, then we go ahead and plot it against the years we've been using them.